So all of you started with the Spring Fest. That is good, but we started that offline mode with your Spring Fest, right? That is good. Okay, so what we are discussing in this DBMS, the major challenge is that if the database is large, right? If the data size is low, then even if there is no database, doesn't matter, right? So long your overall data size is low. And problem is when the data size is pretty large, especially with the large databases like many of you may be working with big data and type of thing. The major problem, we are not going to the big data concept as well. Major problem is that we need to have a lot of to and fro from the backend database. Okay. In other sense, the backend database, as we are looking at the storage, etc., they are stored in secondary disk. Even with today's SSD and other things, this type of to and fro is a challenge, right? And especially things become more difficult, more challenging. I should not say same difficult when we have say a small set of data or record need to be retrieved from a large database, right? I want to see that find those students who have taken DBMS as elective among the whole student database from IIT Kharagpur, right? That maybe you are around who are taken this time elective is around 50 plus, right? 53 or 54. So that is and you may be churning a 12,000 plus hot data, right? And even if you look at the bank database or even something with the stock market and financial database, the things becomes more challenging. So therefore the database needs a mechanism for indexing. Right? So that is intuitive also. Like we do the most good best analogy is our index of our books, right? So you go to that index, search it and go to the index. Right? And as we know that the same database can be searched for different type of with different type of so-called search keys. So sometimes it may be like for a book, it can be or in a library by author, or indexing by the title, or indexing by the subject, or maybe something say domain also, right? Like engineering, arts, and other etc. So there can be different way of looking at the those mechanisms. Right? Nevertheless, indexing plays a vital role in accessing the data. Rather, we'll see that vis-a-vis indexing, we'll have another thing called hashing. You may be using hash function for other purposes also. So it's a mechanism used to speed up the access of the desired data. So that my access rate is high, so that I have a small index like you do in the book index. You find that you are looking for something with P, and then look at the particular subject and hit that page directly, right? On other than going for a sequential search where that particular thing is there, right? So the search key attribute, or it may be a one attribute or set of attribute used to look up the records in a file. Right? So this key and our original concept of primary and secondary or primary or candidate key or your super key, those two key are not the same type of key, but nevertheless number of times we do indexing over the primary key. That's a different issue, but this key is for index key, right? So primarily for searching the thing, right? So one of the best way of one of the things already you have seen that searching or read and implemented for your in the algo of or the data structure and algorithms and things like that, where you have that different type of search mechanisms where you basically search over a key, right? Here also the things are synonymous. So index file consists of a record called index entries and of the for search key and the pointer. So in other sense, like in our book, the index was a set of search keys along with the pointer pointing or the page number, which is pointing to the where the record is there. Here also, what we find that it should have a key and the pointer. So typically, and what our basic assumption or basic means takeaway that my overall this index file is much less than the database file. Had it been in somewhat in the same thing, then there was no gain out of it. So what we are finding that overall the index will be much less. Like your index of the book is typically 3-4 page of a book of say 400 page books, right? So that means in searching or even bringing it to the main memory will be, or processing on the main memory will be much easier if I have a index file, right? And broadly, there are two kinds. One is order indices, that the search keys are in a sorted order, very popularly used or easy to correlate. Other is the hash indices, right, where the search keys are distributed uniformly across different buckets, right? And using a hash function. So depending on the hash function, I say this block is here, this block. That we'll see that, or you might have used in some other context also, this hashing. So what we try to see that whether my index is a good or how good is my indexes, especially when my databases is pretty large. One is that what the access type, like records with a specified value in the attribute, or records with an attribute value filling in a specified range on the things. So that is the access types what we want to do. What is my access time? What are the different time maximum in a large database? What we do is more of a accessing, right? Insert and delete. Delete actually, most of the cases in databases we do not encourage deletion, right? So rather, why we go for the database? Because we have a somewhat persistent over a large data set, right? Like, so that I can do analysis across the thing. So anyway, access time for running queries and reading the things, insert, delete, and space override, right? So how much space this index is taking? If it is taking a large space, or even for the doing a insert, it has to do a lot of other process. Then we have a things of different things. So these are the things: access time, insertion, deletion time, and the space override. This way we want to help. So in case of an ordered index, you like to have water. Someone can give. So in case of an ordered indices, so in an ordered index, index entries are stored in a search key value, like authors in the catalog. Like if you go to the central library, nowadays we are not used to that. Actually, you are. So during our PhD time, that there was no as such getting your things on the net. So you have to be on the author list and then drag on the things. It was interesting. Sometimes, at least for experimentation, once visit library, so they have a index on the authors, index on the subjects. So and there is a concept of primary index. That means a sequential ordered file index whose search keys satisfies the sequential order of the file. And also called clustering index. The search key in the primary index is usually the primary key, not necessarily. Like here, if I have my this particular instructor relation, which is being used in this book. So if we have that instructor ID or the employee ID, so that is the primary key. So your typically here the this over our primary index or the primary index key is the this primary key itself, but not necessarily. It is a something which is being in practice, right? So, and secondary index, you can have multiple secondary indices, right? So, an index whose search key specifies an order different from the sequential order of the file, also called the non-clustering index. Right? So, index sequential file ordered sequential with the primary index. Right? So, if I have an index sequential file, ordered sequential in the things. Or in other sense, suppose this is my index file on the left. So, what we are doing, we basically, if you want to search something, say employee code 2322 something 43, then I have there and then go to the pointer. As this particular index file takes much less space than the overall thing, then I can go on the so that this searching is easier. Then I fall back and bring this record from the secondary storage. Right? So these are this data is lying on your secondary storage. So you want to bring that, right? So there are interlinked between these records. So I can go for where, then I can go down sequentially if I want to do a range type of things, right? From say like roll number so and so, I want to do some allocation, right? Like say in our case, like employee code is start with the year of joining this institute. So something is there that whoever joined between say 2000 and 2010 will have something like you need to pay so much income tax and these other things, other facilities, etc. So it is basically based on it. So once I hit that, as the first two digits is my employee that year of joining. So if it is my primary key, in our case that is our primary key, and if it is this sort of index, then I can go to a range of data sequencing. So so dense index files, that index record appears for every search key. So for every search key there is a index record, right? But it may so happen. So this is dense index of the instructor, right? What we go for a attribute is that ID or the primary key of the instructor, which is the employee ID or the instructor ID. Whereas here the dense index in the department name, right? So where department like biology, computer science, electrical engineering, finance, etc., etc., there, and the index is on the basis of the department name. Right? So it can be the search can be different way. So how many? What are the indexes you will be making based on the your business logic, right? So if you have a academic institute, so like in our ERP, they want to see that what sort of queries are coming, so that I want to make it fast, right? So one is churning this, mining these queries and see that which are the records, how things are recorded. Otherwise, most of the cases there is a definite business logic behind the things, right? Academic department for their academic, for all this academic activity, we have a something rules and regulations for that, right? Which you all are following. Basis on that, we create that indexing. Right? Like here, it may be while making this allocation of the rooms. So what we need to see that how many students are there. So if it is less than 50, there is a logic that you push it to the department to first try in the department whether the rooms are available. Otherwise, come to this central facility like Nalanda. And if it is 50, then you go for that, which sort of, so there is a room table which says that these are the rooms, how much capacity is there. Just forget it. Clear instruction from the institute that you should be COVID protocol. So anyway, don't announce that SKG didn't look, we are sitting together, they will not catch you. No, mask, whether you are. So distributed properly, that's why those very good things. Anyway. Okay, so it depends on that what are the different type of indexes they are followed, right? And there can be sparse index, right? So I have that not all the employee IDs, as I know that those are in sequential thing. So what I do that in between that sparse thing, right? So that my index table becomes much less, and so my searching will be much faster. And I basically then I go for a sequential things, right? So contains index records for only some search keys, key values, right? Available when the records are sequentially ordered in the search key. So that is obvious, right? Otherwise you cannot do that type of thing. So to locate a record in the search key, value k, we find the index with the largest search key, that is which is less than k, and then go on searching to the things, right? So the search key or maybe less than equal to k, right? So search key sequentially starting at the record to which the index record points to. So I have a sparse index, right? So this becomes things. Now suppose you have a 1 million data, then making an index table with even 1 million ID with pointers, that may itself is such a large space. You cannot again you have to make a another level of indexing. Anyway, that hierarchical indexing is always possible. I have a set of indexing, then another set of indexing and things like that. Right? So when we index, what we go on doing it, first of all, it takes a space. It takes a time to index it. So long there is not very much update operation, insert delete type of operation, you are safe, right? If the database is very volatile, that means being updated very frequently, then your index also go on churning, right? Suppose couple of records are deleted, then it go on churning the things. So compared to dense index, like what we have seen here, this sparse index have less space and less maintenance overhead for insertion and deletion. For this type of index, suppose if I delete 222 from the thing, trying to locate that, you do it by the regulator. It is stopped. You can even, if you are finding that, you can come here and sit that also if it is comfortable. No. Okay. So in case of this type of dense index, suppose one record is deleted, then again you have to rebuild it, right? First of all, you need to remember that where it is deleted, because next otherwise it will go on creating space. Suppose I delete all these 2s and say 5, 8, some 3, 4 records out of it. So those will be here blank. Either you need to again compact it, right? And then next time some data is inserted, whether you insert there. If you insert there, then again you have to rebuild the thing because it should come in a sequential thing, right? So there is a lot of challenges while if there are a lot of updates on the things. Luckily, in the databases, these deletions are less, right? So usually we have an update on the things. Nevertheless, it's a challenge. But whereas in case of a sparse, still we can manage because within the range I am seeing that who are there. Then I am thinking that I either insert here and go on a sequence. So it is that find record of the largest key value, search sequentially starting from this, and what we see that generally slower than the dense index for locating records. Definitely, it has to first sequentially go there and then locate the record and type of things. Right? Not only that, now at the database you are recording a chunk of records. Right? Then you go sequential and see what is the thing. Right? So there is a good trade-off. The sparse index with the index entry for every block of the file corresponding to a least search value in the block and type of things. Right? So I have a making a trade-off out of it. So there can be primary and secondary indices, as we have seen. Indices offer substantial benefits when searching for records, but updating indices imposes overhead of the database modification. Right? When a file is moved, every index on the file must be updated. Right? Because all thing has gone for a spin. Right? Suppose a chapter of the book is deleted or few pages deleted and you make it compact, then everything has to be recomputed, right? That pointing to the things. Right? If that is the scenario comes into the things. Things happen for our sometimes for our not our online directory management and that telephone directory or contact list management. Suppose somebody is deleted and then the page number goes for a spin or the where it. So sequential scan using primary index is efficient, but a sequential scan using secondary index is expensive. So primary index, because by default it is sequential, so it is definitely efficient. But when the secondary indices you are giving, then it is not in that order, right? So it is that may be expensive. So each record access may fetch a new block from the disk Log fetch requires maybe 5 to 10 milliseconds. These days little less because of this SDD and type of things. Versus 100 nanoseconds for memory access if you are in the main memory type of things. So, so what we have is a frequency. So one wants to find all records whose values in a certain range, whose values appears in a certain range, which is not in the search key of the primary key, satisfies some condition in the instructor relation stored sequentially by ID. We may want to find all instructor in a particular department. So that may be the things, all instructor of CS department, all faculty of the CS department, all say students, say third year students of a CS department from all list and all those things may be there. As above, but where we want to find all instructor with a specific salary or with a salary in a specified range, right? So along with that, we want to find out that within this salary range who are there or this designation who are there. So those way it is not stored. In our things are like say for our case, either it is stored in alphabetically order of the instructor or the faculty, or usually the institute stores everything in the sequence of the employee code, which primarily dictates by the date of joining of the employee. Whether if even an employee joined as something and gone on a say get promotion or shifted to something and etc. Nevertheless, his employee code, his or her employee code will not change. But its designation, department, especially if you see our office staff, so every 3 years mostly they change their locations. Right? So today they are in maybe CS department, you will find them in the something say mining in after 2 to 3 years, right? And maybe in academic administration. But that way their employee code is not changing. If you change the employee code, all other calculation will go for a spin, right? If you can't, because especially not only government, if you consider private thing also, they are a lot of things are dependent on how what is your experience in that organization, benefits and other things, right? Anyway, so we can have secondary indexes with an index record for each search key value, right? So we can have another index, secondary index, which has a salary thing, right? So secondary index on the salary field of the instructor. So I can have, other than my primary index, now the salary field on the instruction, which is nowhere in the sequential order, right? Because first of all, the salary is a mutable thing, right? Like every yearly, typically in our government structure, we have a yearly increment thing. Unless something gone very wrong, that person will get a increment, right? Anyway, if you did extremely well, also you may not get a. Means again, you will get that increment only. Right? So unlike say other organizations or private organizations, it is performance based. Here you may get a director may give you a watch that you have done a good work and things like that. And anyway, that's a different thing. But nevertheless, increments are there, so salary is changing. Right? Increments again differ with different type of designations. Right. So my increment will be different from somebody else's increment things. It is not fixed, right? It is a percentage of your basic salary. In other sense, this right hand side things may mutate. Right? Sometimes I am higher, usually not there, but anyway, sometimes I am lower than the other person, etc. That may happen. Somebody gets promotion and other things, right? So index records points to a bucket and contains a pointers to all actual records with a particular search key values. Right? So secondary indexes has to be dense, like so has to connect to the all the things. So not only that, we can have multi-level indexes. So in other sense, so I have a set of index, I can have one thing, and then I can have hierarchical multi-level indexes, so that my way of searching becomes. So what we see indirectly, we are going for some sort of a search where this type of tree structure is building up on the index, not on the record. Right? Record you cannot do much because it's a huge volume chunk of things. Most of the things may come from a transactional data sets, right? And it has to be there in the thing. But searching the record is our major challenge, right? Querying on the data is the major challenge, right? Whether access the querying or for on the read access is the primary thing, means the primary thing is the, what do I say, the most used operations, other than we have a write and delete options also, but usually that is, or update options also, but that is the thing. So what we see that it is building up, or you may now may argue that I could have done this in a nicely in some sort of a tree, like maybe making some sort of a binary type of tree, right? Or binary search tree where you can search in a much easier fashion. Absolutely fine. Actually, we are heading towards that only. So what we are looking at, that somewhere or other, if I can find where things, it will fall back to the backend database. So when we go for index update, so one is the insertion, right? Perform a lookup using the search key value appearing in the record to be inserted. And if the search key value does not appear on the index, insert a index entry in the search key value in the index in the appropriate position. Very straightforward, but very difficult thing, right? Suppose you get something and then you want to insert, then rest of the thing has to be pushed down. Say I have something primary key 111 and 222, then you say that I want to insert 115, then 222 onwards, rest of the thing has to be pushed out. And if there is a 1 million data, then pushing these things and rebuilding the instance is a very costly affair, right? And if those things happens more frequently, then things becomes a serious challenge, right? So otherwise, if the index entry stores pointer to all the records in the same search key, add a pointers to the new record in the index entry. Right. Otherwise, the index entry stores a pointer only to the first record of the search key, then place the record being inserted on the other things. In other sense, if the entry is there, I put that appropriate pointer, or I can put, rather I can example in the book, you will find that example. So otherwise I put in the where the free space is there and attach that pointer to the things, and then rebuild the index when it is not on the active time, right? Most of the large databases, they rebuild when it is not the peak hours, right? Peak time, if you go on rebuilding the things, then it will be a huge costly affair. For sparse index, assume that the index stores an entry for each block. If the system creates a new block, it inserts the first search key in the key order, appears in the new block of the index. So I have the block of the things. If you are inserting, so I have the first search key for the block, and rest I know that where it will end. On other hand, if the new record has the least search key video in the thing, use the index entry pointing to the block. If not, make the no change in the things. So if it is already within the things, I push it into the within that block. Otherwise, I add a new block to the thing. Update is update, especially if there is a deletion. So there are challenges. If the deleted record was not only was the only record with the particular search key value, the corresponding index is deleted from the index also, right? So that means is especially true if you have the primary index where you delete it and records are deleted. But suppose if you want to delete something like with the department wise computer science deleted, let us not delete the computer science, suppose department X is deleted, then you have a problem, right? Then you have to find out that where the things are appearing and things like that, right? Okay. Similarly, if the key does not contain in the index entry of the search key value, the deleted record, nothing needs to be done. That means if it is if the deletion for the sparse index, we have the only the in between things, right? So if it is not affecting that, then in between I don't have to do anything. That is deleted, but I don't have to do what we are looking at the index point of view. The deletion etc. is in the database things, right? So whatever way, mostly the database will not delete the record, right? Database will mark it as a not available or deleted type of things with a special character or something, right? Different database have different mechanism to that. It will not delete because tomorrow you may look for the there may be a requirement for the recovering the data. there may be requirement for some forensic analysis, etc. Or deletion and again rebuilding is always a costly affair. Okay. So usually that will not go for deletion, rather go for the index. Now we'll look into the B tree, B plus tree maybe tomorrow. So B plus tree is one of the very popular. B plus tree you have studied? You have not, right? So B plus tree was one of the very popular, rather de facto standard for indexing in case of our all this relational database. Rather, the family is called B star tree. So we have B tree, B plus tree, and there are other variants also, and there are other type of things like R plus T. Anyway, we are not doing those things. So what we found, the disadvantage of the index sequential file as performance degrades if the file as the file grows, since many overflow blocks will be created. Right. So if you go on doing that, so you are not able to insert them. So you will see, refer to the book, you will see that what it is doing, it is basically now pointing but adding at the end of the things, right, without disturbing the actual structure. Now, if there is a huge over the time, there will be a lot of overload on the things, or if there will be a requirement of re-indexing the things, right? So periodic reorganization of the entire file is required. Right? So for the sequential things, so if you see, so most of the cases, all our standard databases are on now B plus tree. So those or some sort of a other tree type of structure. Otherwise, if you could see previously, I think you might not have heard of the things like FoxPro, other different type of databases were there, which are those type of sequential. So you need to, before doing anything, you need to generate or regenerate the index. So it will again, the database will be. So advantage of the B plus tree is that automatically reorganize itself with small local changes in phase of insertion and deletion. Right. So it go on reorganization. Reorganization of the entire file is not required to maintain the performance. So that means you'll see that when we look at the examples, that it is a very localized reorganization may help. So it not require the whole index reorganization of the things. Right? There is some disadvantages. Extra insertion, deletion, overhead, space overhead is there. As mentioned, this is considered to be minor, and overall advantages is definitely is what you can say overpower the disadvantages are there. So it is being extensively used at this stage. So it is something looks like this. So we have this key along with the pointings, the things. So if so the pointers is the thing. So every key, every node other than the root and the leaf, they have a minimum number of keys which they can hold. Right. So if there is an insertion or minimum and max, right? So n by 2 or ceiling of n by 2 to n, if there are in such nodes, is the restriction on the things. So if there is an insertion or deletion, so this locally handling this particular level may able to do that, right? So if there is a deletion of this Srinivasan, so I can delete and reorganize this structure in the other things, right? We'll see that how it handles. So what it will see, though it requires a temporarily some space and overhead of doing that, but overall there is no ripple in the whole index. The major problem is there is a ripple in the whole index, then you may be in a problem, right? Okay, let us stop here today. Tomorrow we'll continue this from this indexing things. So if you have any query now, good, we can answer. We can let me come to your online friends. So those who of you are online, your in-person friends can view you, but you can't anyway. Okay, if you have any query, fine. Otherwise, we'll let me unshare this. Let me stop this recording.